All right, here we go. Problem number 1. Oh my, it is a huge exponent simplification thing. Okay, tell me what you remember.
You take the -2 to 3, so it would just be 3 to the -2nd.
Okay, so basically what you're saying is everything in here would need to have that -2 applied to it?
Yeah.
Does that make sense? Okay, so that's everything, so you're right. So it's gonna be 3 to the -2nd. Now, x to the what? What do I do with these two exponents? Multiply them. When you have one letter and a double exponent, you multiply. Now, if you had x squared x to the -6, if you had 2 letters, then you add them. But if you have just one letter and a double exponent, it's going to get multiplied. So this will become y to the 14th and 4 to the -2nd and x to the -8 and y to the -4. Does that make sense to everybody? Yes. Now, one thing we'll talk about more is that the order that we do that doesn't matter. You chose to kind of distribute the exponent first, and that's fine. But you don't have to start that way, but it's fine. It's fine to start that way. Now what do? This is a real mess. What do I do with this?
Don't you just simplify the ones without the variables and then you combine the ones like you add or subtract or flip it first?
Yep, I said yes, so I need to take care of all these negative exponents. That's gonna be my next step. I'm gonna get rid of anything that's negative. And to get rid of what's negative, so I'm gonna have to deal with this, and this, and this, and this, and this. All those things I have to deal with. And when I say deal with them, I mean move them. A negative exponent moves you. So this is going to become 3 squared in the denominator. He's in the top, so he's got to move to the bottom. This becomes x to the 12 in the bottom. Now this guy stays right where he is. He has a positive exponent, so he's not moving. This guy's in the bottom, so he's going to the top. This guy's in the bottom, so he's going to the top. And this guy's going to the top. So now I have no more negative exponents. And I can do what you suggested now. I've got 4 squared, which is 16, and 3 squared, which is 9. Now, what's going to happen to these guys right here? Well, the official rule is I'm going to subtract the exponents, but what's going to happen when I subtract the exponents? I'm going to get a negative. That's right. So that x to the 4th is going to end up in the bottom, isn't it? And that makes sense if you think about it, kids, because x to the 8th means x, 8 of them, right? And this means 12 of them. So when you start canceling, if you only have 8 on the top, but you have 12 on the bottom, aren't you going to have a leftover 4 on the bottom? That makes perfectly good sense. Now, these two are not going to cancel because they're both on the top. So this is a case where I am going to add those exponents. So that's going to be y to the, what, 18th? And there's your answer. Now, those steps that we did can be interchanged. What I mean is you didn't have to do it in exactly the order that you did it. If I were doing the problem, probably the first thing I would have done is simplify in here. So take care of these x's, take care of these y's, and then I would do my deal with the outside exponent. But it doesn't matter. This is perfectly fine. That's the answer. Good job. All right, now naming the property.
Okay, I have a question.
Yep.
When we're doing homework like this and you want us to show our work,
Yep.
do we just, if there's not enough space, can we just do it on either a separate piece of paper on a notability?
Yeah. So if you do have another sheet of paper, just make sure you staple it to this one when you turn it in. Yep, yep. All right, name the property. Okay, do you know anything about, look at all those. Do you know any of those? A, B, C, or D? Again, on Monday, when we do our notes, we'll go through these carefully, but just by chance, do you remember any of them?
Is the first one, there's A, multiplication?
Well, it's the multiplicative inverse. It's the multiplicative inverse. Because when you multiply a number and its reciprocal, they cancel out, right? That's what it means to be an inverse. So A is the multiplicative inverse, and you can abbreviate that. So it definitely is multiplication, and it's the inverse property. Now, D, I'm skipping down to D, it is definitely addition, but it's the identity property. Because when you add 0, you get the same thing back again, the identical thing back again. So you have the inverse properties that cancel out, and then you have the identities that give you the same number that you started with. Now C, I should have done C. C is the additive inverse. What happens when you add 15 and negative 15? Don't they cancel out? Anytime things cancel, it's an inverse property. This one happens to be addition. Do you see the similarity between A and C? They're both cancellations. One's a multiply and one is an addition. Perfect. Now what about B? Forget the parentheses, just read the letters. On the left side, it's A, B, C, and on the right side, it's A, C, D. Wait a minute, what changed? The order. When the order changes, it's commutative. Have you heard that word before? Yes, you have. It's commutative, and we are multiplying. So it's the commutative property of multiplication. When the order changes, it's commutative. So an associative, that's kind of the one we study when we do commutative. We also study associative. The associative looks like this. Notice that on both sides the order is exactly the same, ABC, ABC. That's not commutative. Commutative is when the order changes. So we haven't had an order change. What did change was the way that we grouped them. So when the grouping changes, it's associative. Think about when you associate with your friends, that's your group. When you're grouping, you're associative. When you're changing the order, you're commuting. You're getting from point A to point B. You're changing position. All right, you okay with that? Okay, write as an inequality and sketch on the number line. I don't know if you guys talked about this notation last year. Does that look familiar to you?
Yeah.
So you know what this means?
Yeah.
What does that mean? Tell me.
The square bracket means it's equal to also.
So it's a closed dot on my number line if I'm graphing it.
And then the 2 is open.
So this is going to be a closed dot. It's going to be an open dot.
Should I say the inequality?
No, tell me how to finish the graph. I'm gonna figure out
Like sketching between them.
color in between. That's exactly right. That's exactly right. This is called interval notation, and the bracket, which by the way is all we use in upper mathematics, so that's how everything will be written. The bracket is always a closed dot, indicates an or equal to, and the parentheses is always an open dot, and indicates just less than or greater than. All right, so yeah, go ahead. What would the what would it look like?
-3 is less than or greater, or less than or equal to x, which is less than 2.
Perfect. That's your inequality. I probably don't have to tell you guys this, but I'm going to anyway. Whenever you write an inequality like this, a compound inequality like this, these symbols should always be less thans. Always. these two numbers should always be in the order they are on the number line. And if you put them in the order they are on the number line, then these will always be less thans. Okay? All right. Simplify and write in scientific notation.
Is the scientific notation with the times 10?
Yep, that's scientific notation. So scientific notation is when you write a number like this instead of writing it like this, right? This is called standard notation. That's scientific notation. So your job is to simplify this. Okay? So I see a calculator coming out, which isn't bad at all. Keep in mind that this is all multiplication. You don't see it, but that's a times in there, right? So the commutative and associative properties tell us that we can go ahead and multiply the 1.8 and the 9.4. What do we get when we do that? 1.8 times 9.4. 16.92. And then we've got a 10 to the 12 times a 10 to the negative third. 10 to the 9th. We add the exponents. We got two 10s, so we're going to add the exponents. Now, is that number in proper scientific notation? No, that's too big, isn't it? So I'm going to have to move that decimal point and make it 1.692. Now, when I do that, I made this number smaller, didn't I? I went from 16 down to 1, so this became smaller, which means my exponent has to get bigger. If these are going to be the same number, if you make the first half smaller, then you're going to have to make the second half bigger. You move the decimal point one place to the left. Okay, one more, and your first homework assignment's done. Isn't this easy? This is so easy. 22 ninths. Write it as a decimal. How do I do that? How do I write 22 ninths as a decimal? What? You divide. This is a division problem. Yeah, it's a division problem. So 22 divided by 9, right? And when I do division, because part of our test will be no calculator, or part of it will be with calculator. So we want to make sure that while we certainly could type that in on our calculator, we want to make sure we can do the division. So remember, we got to add some zeros probably. And 9 goes into 22, what, twice? And 4 times. Uh-oh. What's happening here? Yeah, it's going to start repeating. So that'll be 2.4, put a bar over the 4. Is that okay with everybody? First homework done. So,